Alright, hello everyone. I will be going over questions number 8 and 9 on the PQs. These questions will be particularly going over Zaytev's rules and Markovnikov rules and what reactions they apply to. Now, I've written out the definitions for both to give you a better understanding of what they are. With Zaytev's rules, will be discussed or mostly defined as the major products in which we'll have more substituted alkenes, and where Markovnikov's rule is the addition of hydrogens that will take place on a carbon with more hydrogens, forming the most stable carbocation. Now, to give you guys a better understanding of this, I have written out some of the reactions down here, in which I will start off with the Zaytev's reaction. First thing I look at is the leaving group, to check if it's a good leaving group or not. And as you can see, bromine is a very good leaving group. The next thing I look at is to see if it's on a tertiary, secondary, or primary carbon. Now, as you can see, this is on a secondary carbon. Lastly, I look at the nucleophile to see whether it's a strong or weak nucleophile. And as you can tell, OH negative here is a very good nucleophile. Now, taking all of these into consideration, one can assume that this is an E2 reaction that is being seen. Now, going into the specific mechanics of this reaction, the reaction first starts off with this nucleophile, or OH, coming to one of the beta carbons, and they attack or take away one of the hydrogens, in which they form H2O. Now, you might be asking, which beta carbon does it take it from? And as you can see, I've drawn up both beta carbons. Now, in Zaytev's reactions, the nucleophile will take hydrogens from the beta carbon that has the least amount of things coming off of it. Now, this is because it will form a more stable structure in the end of the reaction. Now, as you can tell between these two, the beta carbon on the right has less things attached to it, less hydrogens, which therefore will be the more stable one, more stable structure being formed from that. Looking at the hydrogen leaving, so when this OH nucleophile comes here and takes the hydrogen away, that forms H2O. Now, the hydrogen, between the hydrogen and the beta carbon here, you have electrons. These electrons, when the hydrogen leaves, will come and try to form a double bond here between this beta carbon and the carbon up here. Now, it can't do this. It's blocked from doing this because of the bromine up here that we're seeing. Now, in order for this double bond to form, this bond has to, between the bromine and this carbon up here has to break, in which this bromine is eliminated. This alpha carbon, or carbon where the leaving group is located, will form a double bond with the beta carbon here, in which you will result in a structure that looks like this. Now, as I said, in order for this double bond to form, bromine has to be eliminated. And as you can tell by that, looking at back to this question up here, as far as Zaytev rules and the type of reaction seen, it would be an elimination reaction, based off of the bromine leaving in order for the double bond to be formed, or having to be eliminated. Now, moving on to question 9, for Markovnikov's, I've written down this reaction down here. Now, in Markovnikov's, as defined by the definition up here, it is the addition of a hydrogen that will take place on a carbon with more hydrogens, this forming a more stable carbocation. Now, going back to the example, looking at the two carbons between the double bond, the carbon that has more hydrogen, which is the carbon on the left side here, will be the one that attacks the hydrogen on the hydrogen bromide seen here. It will attack this hydrogen, and the hydrogen will go to this carbon here, because it has more hydrogens coming off of it. This in part forming a more stable carbocation down later when the reaction is completed. Now, you have to, in order for the reaction to occur, in order to take the hydrogen, you have to separate the HBr into its basic components of H plus ions and bromine negative ions. Now, when you do this, the double bond seen between these two carbons will break off from this carbon here with a lesser amount of hydrogens, in which the double bond that from the carbon with the more hydrogens attached will come and attach onto this hydrogen. Now, when this hydrogen is brought back to this carbon, in which this double bond attaches to this hydrogen here, you will form a reaction. You will form a compound that looks like this, where 3 hydrogens are attached to that carbon. And a carbocation is formed on this carbon with the less amount of hydrogens, because the electrons that were shared between the 2 carbons here with the double bonds are taken away when the bond between the carbon and hydrogen are formed on this side, forming a carbocation. But now you have a bromine negative still left around, floating around. Now, this bromine negative and this positive will interact. As we know, opposites attract, so the bromine will be attracted or added onto the carbon or carbocation seen here, in which the structure that results will look something like this, with the bromine attached here. Now, going back up to this problem, Markovnikov rule applies to what reaction. We know a bromine has to be added onto the carbon here, in which the double bond is lost. And through that addition of the bromine, you could call this an addition reaction. This being the opposite of what we saw with Zaytev's rule, in which the bromine was left or eliminated off in order for a double bond to be formed. In a sense, they are polar opposite reactions of each other. Now, I hope this helped you out in better understanding the problem itself, and I hope you enjoyed this video and found it helpful and intuitive. Yeah, and I hope you have a blessed day.